then, corn children, children of the corn. It is a fine day for mathematics, and we are going to be talking about piecewise, there we go, focus up, piecewise functions. What are piecewise functions? Well, first of all, you're going to identify or recognize a piecewise function by this crazy notation. Look how scary it is. I think of piecewise functions like Frankenfunctions, like the Frankenstein monster. We're going to take two functions, cut them up, and stitch them together. So what we see here is a single function that is in 1, 2 pieces. Yes, yes it is. Awesome. Now, when we want to make sense of these functions, we kind of need to look at 3 different parts. Well, in this one, 3 different parts. The first part of our graph is going to be x plus 1. Now, you may recognize that as mx plus b form. The first part of our graph is going to be, this part right here, is going to be a line. So our Frankenfunction, our piecewise function, is going to start with a line. Yeah, it is. And then the next piece, what do we see? Oh, look right here. That is a parabola. It's an upside down parabola, isn't it? Parabola. So we are going to take a line and a parabola and stitch them together. We'll talk about this third piece in just 1 second. So if we needed to graph this, one way that we could graph this is by using an XY chart. Yeah, we could. You know how XY charts go. We put X's down, we take those X's, we fill them in, and we get the Y coordinates. Yeah. So let's say I wanted to do that, and let's say I wanted to put in, trust me, I wanted to put in things like -5, -3, -2, -1, 0, 1, 2, 3. That's kind of a lot of points, but I could do all of those, and I'm not actually going to do all of them. Well, maybe I could. All right, so here's the deal, though. When we have a piecewise function, we take our x and we need to fill it in. But where? There's a line piece and a parabola piece. Well, look at this stuff on the side. This is giving you the rules. When x is less than -2, if you have an x that's less than -2, you're supposed to use the line. You would not use the parabola. But if x is greater than or equal to -2, you would use the parabola. Yes, you would. All right, so let's check this out. Our first x is -5. Here's what you ask yourself. Which place would -5 make the inequality true? Is -5 less than -2, or is -5 greater than or equal to -2? Well, I'm hoping you took Algebra 1 or 7th grade math, and you know that -5, if we put the -5 in, is less than -2. So that means -5 is on the line piece. Yeah. So if I put -5 into the equation, -5 plus 1 is -4. So there would be a point, I'm just going to go ahead and do this, on the line at -5, -4. All right, -3. -3 is less than a -2. So that makes -3 on the line piece. I will only fill it into the line piece. -3 plus 1 is -2. So now I have 2 points on my line. Yeah, I do. Now, what about -2? Is -2 less than -2? No. Is -2 greater than or equal to -2? The equal to says yes. This will be on my parabola piece. So I will put -2 in order of operations. You square the -2 first, which makes it a +4. Then you multiply by the negative. That is -4. So there's a point on my parabola at -2, -4. And we could keep going, and I can do these real quickly for you. If you fill -1 in, it's greater than -2. So all of these remaining ones are going to be bigger than -2. So all of those would be on my parabola. Yeah, that's just how it worked out. So filling in -1, you square it first, then you multiply by the negative, you get -1. Filling in 0, you get 0. Filling in 1, -1, -4, -9. And these are all parabola pieces. Now, I could just go ahead and plot all of those. Do you want me to? Okay, I will. All right, here we go. So there was a dot at -5. 1, 2, 2, 3, 4, 5. 1, 2, 3, 4. There's a dot at -3, -2. There was a dot at -2, -4. There was a dot at -1, -1. 0, 0, 1, 2, -4, 3, 4, 5, 6, 7, 8, 9. All right, so I have plotted all of our little dots, and it looks a little wackadoodle, I know. But let's remember something. Those were the line dots, weren't they? Those 2 dots came off of the line. Yeah, they did. And then the rest of the dots were part of the parabola. So here's what I have. I'm going to have a line on the left of -2 and a parabola on the right. Yeah, I am. Now we need to be a little bit more careful though. What I'm going to do to finish this out is I want to consider very specifically -2. Now we already know at -2 there's a dot. Because of the equal to, there's a dot at -4. I'm going to emphasize that there is a point there by making a little dot. That is on my parabola, and it is a dot. But here's the crazy part. Remember, we don't have to stick to integers. There are numbers between -3 and -2. There's numbers like -2.5. -2.1, -2.01. There are numbers in between here that would get very, very close to -2, but just be a little bit less than -2. So here's the idea. Even though -2 is not part of this piece, I'm going to put -2 in anyway. What? You can't do that. Trust me. Here's the idea. When I put -2 into this, I get -1. But there will not be a dot at -1. But I could get really close to these coordinates. Like if I put in -2.00001, it'd be really, really close to this. Well, mathematically, we can represent that with an open circle, meaning you get close to it, wicked close to it, but you never actually touch it. I like to call this the transition. These are the transition point and circle from where we switch from the line onto the parabola. So I'm going to add a circle at -2, -1. And that is where my line is going to abruptly stop. All right, so here's what I'm going to have. I am going to have a line up to the circle at -2, 1. This is when x is less than -2. And I'm going to have a parabola beginning at that dot at -2, 4, an upside down parabola from -2 to the right, including the dot at -2. And this, ladies and gentlemen, is my piecewise function. This whole thing, all of it together, would pass the vertical line test. It is a function. It's not two separate functions. This whole thing is f of x. Yeah, piecewise function. Enjoy.